Hello! I know this problem looks a little bit scary, but it's time to be brave and read some applications of derivatives. A Cepheid variable star is a star whose brightness alternately increases and decreases. I was not sure what it means, so I searched on Wikipedia and I found this amazing information. Apparently, it's a type of a variable star that pulsates radially, varying in both diameters and temperature. That is pretty cool, you have to say that. It changes in brightness with a well-defined stable period and amplitude. They imported cosmic benchmarks for scaling galactic and extragalactic distances. And they definitely are described through pulsation period, which is pretty cool too. And of course, they have sines and cosines there, and that's why you see a sign in the function in front of you. So apparently, they call it stellar pulsation. How cool is that? Stellar pulsation. And here's the graph. It also looks pretty amazing. Well, let's go back to the problem. We have the function given for this specific Cepheid variable star. A star for which the interval between times of maximum brightness is 6.1 days. That's why it's over here. Its average brightness is 4.6, and this is the average. And the brightness changes by plus or minus 0.55. Here you go. Using this data, we can construct a mathematical model. Okay, we did. Well, let's pretend that we did that. Someone smarter did it for us. Find the rate of change of the brightness after t days. Remember, if you see the rate of change, not the average though, the instantaneous rate of change or just rate of change, that means they wanted to take the derivative of this function. Basically, they wanted to practice chain rule. B prime of t is 4.6 gives you 0 plus 0.55 constant will survive because it's multiplied by a function we're going to differentiate, so it's a rate. And remember, it actually does say that its brightness changes by the rate plus minus 0.55. Derivative of sine is cosine. Copy the function inside. So I'm going to copy 2 pi t divided by 6.1. And now multiply by the derivative of the function inside. So I'm going to multiply by the derivative of 2 pi t over 6.1. 6.1. To help you to figure out how to take this derivative, I only need to see a variable. The variable inside is t. Thus, everything else is a constant. So, when I differentiate this function, 2 pi over 6.1 t, the derivative will be 2 pi over 6.1, because it looks like so, 2 pi over 6.1 multiplied by t prime. And that is the answer, so don't overthink this too much. If you need to simplify the result, it's going to be 0.55 cosine of 2 pi over 6.1 t. Well, what did I just do? I wanted to simplify 0.55 and 2 pi over 6.1. It becomes 1.1 pi over 6.1. That is the idea here. I just multiplied 0.55 by 2. So this is the answer for A. For B, they just want us to substitute a value. Find the rate of increase after 1 day. I need to check the units for t. If t is measured in years, that's going to be 365 days, right? So I will have to divide by that. In months, 30 or 31, and so on. Luckily for us, t is measured in days. Thus, I just need to substitute 1. For b, I need to find b prime at 1. And guess what? You don't have to simplify anything. Just write down 1.1 pi over 6.1 multiplied by cosine of 2 pi over 6.1 times 1. And that is the final answer. You can type this in carefully into your homework problem. I actually went ahead and checked the decimal answer for this problem, which I don't recommend to use in online homework problems because sometimes they need 7 decimals or 5 decimals. Try to type 5 to 6 decimals if you can, but I only have 4 decimals. In general, the exact answer is much better. And this is how you work with problems like this. Keep working hard.